Algebra Chapter 1, Lesson 5, and we're looking at the distributive property. And before we take our next step, I just want to review quickly some of the things that we've looked at so far so you can begin to see how extremely important this property is. So some of the things we've talked about already, the distributive property allows us to take a number that's outside the expression and multiply the terms inside. So we can multiply a quantity or a parentheses by a number that's outside. The expression inside is either subtraction or addition. We talked about the distributive property being the only way that we can remove parentheses from an expression. We talked about how when we distribute, how each resulting term then contains that number that's on the outside. It's now a factor of these new terms, and because it's a factor of those new terms, we're able to use the distributive property in reverse to factor out then that number that was multiplied in. So those are some of the things that we've looked at so far. And we're really going to use this kind of application of the reverse or the factoring to help us with our next topic, which is like terms. Okay, I'm not sure how much exposure you've had to like terms, so we'll begin by looking at the definition of like terms, how do we recognize like terms, and then we'll look at how the distributive property helps us to add like terms. Okay, some vocabulary first we need to go over. And in an algebraic expression, a term is a number. So a term can be just a number. It can be a variable, so it can be just a letter. Or the product of, product meaning a multiplication of numbers and one or more variables. So those are what each term or what a term is. Now, I've been using that phrase quite a bit, and I think you kind of intuitively know what it is, but we'll put some definition to it here. So a term is either a number all by itself, a variable all by itself, or a product of numbers and variables, meaning like this term here, 5ab. That's a number times a times b. So it's a number times more than one variable. 3b is a number times a single variable. So each one of these separate entities kind of within the expression is called a term. So these are some different expressions of a term. So it could be a number, a letter, or a product of number and letter, or even just a product of letters. Okay, as we read further, we see here that a constant is a term with no variable. Okay, and again, we'll talk a lot about constants in the future, so make sure we get this definition down. If we're taking notes, we're changing colors because we have a new concept we're talking about. A constant is a term that has no variable. And it's called a constant because what happens? If it has no variable, the constant remains the same. It doesn't change. In other words, this constant here, 12, 12 is always 12. 12 cannot be anything else. This is, in this expression, 3 times b, and b can be anything. So this term can change because if b is 1, then that's a 3. If b is 7, well, now that's a 21. So it can change. So a constant never changes, and the only way something will never change is if there's no variable attached to it. So a constant is going to be a number, okay? Because numbers never change. And then another very important term here is a coefficient. Please notice the spelling, 1 E, 2 F's, and it is a numerical factor of a term. Okay, so if a term is a multiplication, that's what 5 times a times b is. Each one of these is a factor. We talked about that earlier in the year. The coefficient is the numerical factor of this, or basically it's the number in front of a variable. Okay, so in this term you have 6 times a squared. 6 is the coefficient. Here 5 times a times b, 5 is the coefficient, etc., etc. So the coefficient basically comes down, again, new concept, so new color in our notes. It's the number that's in front of a variable. Okay, and it doesn't matter how many variables that you have, it's the number that's in front of it. Now, can you ever have two coefficients? Well, no, because if you have two numbers in one expression, you need to simplify that expression, so you would multiply those two numbers together to give you the one number, and then that would be your coefficient. Okay, so those are some very important terms that are going to be very important. In the next video, we'll talk about like terms, what makes terms like, and then finally we'll look at how we can add those terms together.